Welcome you to the deep dive. Today, we're plunging headfirst into a topic that's, well, not just fascinating, but genuinely reshaping our world every single day. Artificial
It
intelligence.
really is everywhere.
It is. It's this rapidly evolving force, often working away without us even realizing it, right?
Hmm.
Think about those next episode recommendations on your streaming services, or
Yeah.
when you chat with the voice assistant on your phone. That's AI right there, quietly but profoundly doing its
King
thing.
its job, yeah.
So our mission today, it isn't just about throwing around buzzwords like AI this and AI that.
Right, we need to get past the hype.
Exactly. We're going to try and strip away the hype, maybe some of the Hollywood fantasies too, and truly explore what AI is at its core. We'll trace its, well, surprising historical roots, uncover the different forms it takes, and then really dig into the groundbreaking technologies that power it all.
The building blocks.
Building blocks. From there, we'll dive into its incredible applications, how it impacts everything from your daily routines to, major global industries.
And the tricky stuff, too.
And crucially, yes, we'll grapple with some of these significant societal and ethical questions that, well, inevitably arise from its rapid development. And finally, we'll try to peer into what AI promises for our future, looking at the cutting edge, what's maybe just over the horizon.
Hmm.
Think of this as your shortcut to being genuinely well-informed on AI. We want to give you those aha moments about a topic that feels like it's constantly in the news, but let's be honest, often misunderstood.
You've hit on a really crucial point there. Understanding AI isn't just about, keeping up with tech trends. It's absolutely vital for critical thinking, especially now with so much information flying around.
Information overload is real.
It is. AI is so transformative that grasping the fundamentals really allows you, the listener, to navigate the constant stream of news, the excited headlines, the sometimes alarming discussions around it, all with far greater insight. It's about being an informed participant, really, in shaping a future that AI will undoubtedly influence.
Right. So let's unpack this then. To truly grasp the AI revolution, we have to start with the most basic question. Expert, when you strip away the sci-fi, how would you define artificial intelligence at its core? What is it?
That's a great place to start because, yeah, the popular image can be a bit misleading, can't it?
Definitely. Robots taking over, that sort of thing.
Exactly. But at its simplest, AI is about the simulation of human intelligence in machines. So we're talking about machines programmed to demonstrate behaviors that, well, if a human did them, we'd say that's intelligent behavior.
Okay, simulation.
But, and this is crucial, AI doesn't think or understand in the human sense, not like we do.
Yeah.
It's more like a very, very sophisticated pattern recognizer and predictor. Making that distinction, I think, is key to dispelling a lot of the sci-fi myths right from the get-go.
Okay, that makes sense. It's about mimicking intelligence, not possessing it in the human way. And what's fascinating, reading through the background here, is that the sort of ideal characteristic of AI is its ability to rationalize and take actions that have the best chance of achieving a specific goal.
It's not just about doing things, but doing them optimally, efficiently, to reach some defined objective.
Precisely. That core idea, machines demonstrating goal-oriented behavior, is vital. Think of it less as a machine becoming human and more about it demonstrating intelligent behavior to accomplish a defined task, efficiently and effectively.
Like winning a game.
Exactly. An AI might be designed to win at chess. Its intelligence there is measured by its ability to find the best move, the optimal move, not by, its ability to write a sonnet or understand human emotion.
Right, different domains.
It's about problem solving and decision making within specific parameters. It often mirrors complex human cognitive processes like planning or strategizing, but it does it through computation, through algorithms.
Now, you might think AI is a really recent thing, maybe just the last decade or two.
Which is understandable given the recent explosion.
Totally. But the idea of intelligent machines, it's actually been floating around in science fiction and philosophy for centuries.
Mhm.
But the formal academic field of AI, that's surprisingly recent. Relatively speaking, yeah.
Get this. Its true birth as a dedicated scientific discipline is often pinpointed to a really important conference at Dartmouth College back in 1956.
The Dartmouth Workshop, yep. Foundational.
Imagine this scene. A small group of brilliant minds get together. We're talking pioneers like John McCarthy, Marvin Minsky, Alan Newell, Herbert A. Simon.
Giants in the field.
Absolute giants. And they were grappling with this bold, almost audacious idea. Could machines actually simulate human thought?
A radical question for the time.
Absolutely. They believed that, and this is called, every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. I mean, that's quite a statement for 1956.
It really was. And what's particularly telling about those early AI efforts, the ones that came out of Dartmouth in the years following, is their focus. They focused on what we now call symbolic reasoning and expert systems.
Okay, what does that mean in practice? Symbolic reasoning.
Well, picture it like this. You're essentially trying to teach a computer a vast set of if-then rules. Like, if you see this symptom, then consider this diagnosis.
Ah, okay. Encoding human knowledge directly.
Exactly. You'd encode human expertise, maybe the rules of chess, or the steps a doctor takes for a specific diagnosis directly into the computer's programming. These systems were attempts to explicitly map out human logic. And they did have some notable successes, but usually in very narrow, very well-defined domains where all the rules were clear and unambiguous.
And a prime example of that early success, one that really caught the public's eye, was IBM's Deep Blue.
Ah, yes, Deep Blue versus Kasparov. Iconic.
Right. In 1997, it famously beat the reigning world chess grandmaster Garry Kasparov. This wasn't just, a computer playing okay chess. It was a machine showing absolute mastery in an incredibly complex, though still, as you said, very narrow intellectual domain.
A major milestone.
It felt like a real aha moment for many, suggesting machines could genuinely compete at the highest intellectual levels, at least in some areas.
However, that triumph also vividly highlighted the inherent limitations of those early approaches. Deep Blue was amazing, but fundamentally it was an incredibly sophisticated chess calculator.
Right. It knew chess rules, but nothing else.
Precisely. These symbolic systems, these rule-based systems, they really struggled with ambiguity. They struggled with common sense reasoning, the kind of background knowledge we humans take for granted. And they especially struggled with tasks that required learning from vast amounts of messy, unstructured data, rather than having rules explicitly programmed in.
Like understanding a joke. Or sarcasm.
Exactly. Things that rely on context and nuance. This fundamental challenge, the inability to generalize beyond the programmed rules, led to what we now call AI winters.
AI winters sounds chilly.
They were. These were periods where funding dried up, research interest cooled, and public enthusiasm for AI just waned significantly. Why? Because the really ambitious promises of general human-like intelligence simply weren't being met by the methods they had at the time. Progress kind of stalled or even went backwards in some areas as researchers hit the limits of those symbolic rule-based approaches.
So we had these periods of disillusionment, these AI winters, but then something huge changed, a real turning point that sparked the modern AI boom we're living through now. And that was the emergence of machine learning, or ML. This wasn't just like a small improvement. You're saying it was a complete paradigm shift.
Absolutely, a fundamental shift in thinking. Instead of explicitly programming rigid rules into a machine if this, then that ML allows systems to learn from data. It's a different way of getting intelligence into the machine.
Okay, learn from data. Let's use that example you mentioned earlier, the cats and dogs one. How does that work with ML?
Right, so imagine showing a computer thousands, maybe millions, of pictures of cats and dogs. With machine learning, you don't write code saying, if it has pointy ears and whiskers, it's probably a cat, or if it barks and wags its tail, it's a dog.
No specific cat rules or dog rules?
None. You simply feed it the pictures, along with labels, this is a cat, this is a dog. The machine then, using complex algorithms, learns to distinguish between them all by itself. It identifies subtle patterns, texture, shapes, features in the data, without you ever having to explicitly define what makes a cat or a dog a dog.
Wow. So the system infers the rules from the example.
That's the elegant power of it, yeah.
It generalizes from the data.
That seems way more powerful.
It is. This paradigm shift was incredibly significant because ML's ability to learn from experience, to adapt its internal parameters, and to improve its performance over time without needing explicit hand-coded programming that's truly the cornerstone of modern AI.
It allowed AI to finally tackle problems that were just impossible before. Problems where the underlying patterns were too complex, too numerous, or maybe just too dynamic for humans to sit down and write out all the rules. Think about recognizing faces in a crowd.
Yeah, impossible to rule-base that.
Exactly. Trying to write rules for every possible angle, lighting condition, expression, forget it. ML sidesteps that by learning the distinguishing features from millions of example faces.
So just to clarify for you listening, when we talk about AI today, especially its big impact everywhere.
Hmm.
We're largely talking about systems powered by these sophisticated machine learning algorithms. These are the systems that can spot intricate patterns in enormous, messy data sets, make predictions with often startling accuracy, and even, generate completely new content, realistic images, human-like text, original music, all based on the vast amounts of data they've been trained on.
It's a completely different beast than the rigid if-then logic of early AI. It's really about learning and generalization from experience.
Okay, that's a perfect setup. It brings us right to our next crucial section, the fundamental building blocks of modern AI. Because, as we've just established, this AI revolution isn't just one monolithic thing.
Not at all. It's a combination of things.
It's built on several interconnected, really powerful technologies. And machine learning, as we've just discussed, is clearly the most prominent pillar, that subset of AI letting systems learn and improve automatically. So, expert, what are the main types of machine learning that are really driving AI today?
Right. So within ML, there are broadly three primary types, and each is suited for different kinds of problems and different kinds of data. The first one is probably the most common. It's called supervised learning.
Supervised, like having a supervisor.
Exactly. The analogy you used earlier, learning with a teacher, is spot on. In supervised learning, the algorithm is trained on a labeled data set,
Labeled dataset, meaning what?
meaning that for every piece of data you feed it, there's a corresponding predefined correct answer or output already attached. Think of it like flashcards for a student question on one side, answer on the other. The algorithm sees the input, the question, and the desired output, the answer, and learns to map between them.
Okay, so back to cats and dogs again. You give it a picture, input, and the label cat, the correct answer. It sees thousands of these pairs.
Precisely. It learns to map the visual features in the image to the correct label, cat or dog. Its power lies in generalizing from those labeled examples. So once it's trained, you can show it a new, unlabeled picture of a cat it's never seen before, and it should correctly classify it.
Makes sense. Where else does this teacher approach really shine, beyond just pictures?
Oh, it's superb for tasks where we have a lot of historical data with known outcomes. So think medical imaging training models on thousands of x-rays already labeled by radiologists as tumor or no tumor. The AI learns the visual patterns associated with tumors, or fraud detection and finance training on past transactions labeled fraudulent or not fraudulent. Email spam filters are another classic example, learning from emails you've marked as spam. Predicting customer churn in business learning from past customer data labeled churned or stayed.
So the challenge is getting all that labeled data.
That's often the biggest hurdle, yes. Meticulously labeling massive data sets can be time-consuming and expensive, often requiring human experts. But once you have that labeled data and train the model, supervised learning can provide highly accurate classifications or predictions for new, unseen data. It's incredibly valuable.
Okay, so that's supervised learning, learning with labels. What's next?
Next, in stark contrast, we have unsupervised learning. And this one really has no teacher, no labels.
No labels at all. How does it learn anything then?
Well, here the algorithm explores unlabeled data on its own. Its goal is to find hidden patterns, structures, or relationships within the data itself without any predefined answers to guide it. Think of it more like an explorer dropped in a new land, trying to figure out the geography, the connections between places, without a map or a guide.
Okay, an explorer. So give us a practical example. Where does this no-teacher approach make sense? How does it find patterns?
A classic relatable example is a recommendation system, like on Netflix or Spotify.
Yeah.
The system isn't explicitly told, these are action movies, these are comedies.
Right, you don't label every movie genre for it.
No. Instead, it looks at the vast unlabeled data of what users watch or listen to. It starts finding patterns, like, users who watched movie A also seem to really like movie B and movie C. Or, users who listen to this obscure indie band also tend to listen to these other specific bands.
Ah, finding connections based purely on behavior.
Exactly. It identifies clusters of similar users or similar items based entirely on these intrinsic relationships in the data. It discovers these hidden connections and structures. Then, it can recommend new content to you because you fall into a cluster of users who liked similar things, or because the items themselves are mathematically similar based on who interacted with them.
So it finds the groups automatically. That's clever.
It's incredibly powerful for things like data compression, finding anomalies like unusual network traffic, or customer segmentation in marketing, any situation where you want to discover inherent groupings or structures within complex, unlabeled data sets.
Okay, supervised with labels, unsupervised without labels. What's the third type?
The third type is reinforcement learning, and this one you can frame as learning through trial and error. Think about how a child learns to ride a bike.
Lots of falling down.
Exactly. Lots of falling down, negative feedback or penalty, and eventually figuring out how to balance and pedal correctly, positive feedback or reward. In reinforcement learning, an AI agent, like a virtual robot or a game player, performs actions within a specific environment.
Okay.
Based on those actions, it receives feedback from the environment, usually in the form of rewards for good performance, moving closer to the goal, or penalties for poor performance, crashing, losing points. Through this continuous cycle of acting, observing the outcome, and getting feedback, it gradually learns the optimal strategy, the best sequence of actions, to maximize its cumulative reward over time.
That sounds like a really interesting way to train an AI, especially for complex stuff. Where is this particularly effective?
It truly shines in dynamic environments where the best path isn't obvious up front, and where trying to program all the rules will be impossible or impractical. Think about training an AI to play complex strategy games like Go or chess.
Like alpha.
AlphaGo is the prime example. It learned to beat the world champion Lee Sedol, largely through reinforcement learning, playing millions of games against itself, learning from wins and losses. It's also foundational for robotics.
How so?
Well, it allows robots to learn how to navigate tricky terrain, how to grasp different objects, or even perform delicate surgical maneuvers by essentially practicing and getting feedback on their performance. Beyond games and robots, it's being applied to optimize logistics in warehouses, figuring out the best routes for robots, manage autonomous vehicles in traffic, and even design chemical processes anywhere. An AI needs to make a sequence of decisions to achieve a long-term goal.
Wow. So those three, supervised, unsupervised, and reinforcement learning, they cover a lot of ground.
They really do. They form the versatile toolkit of modern machine learning, making it the foundational technology underpinning so much of today's AI progress.
Okay, moving beyond general machine learning, there's a specialized, super powerful subset that you hear about constantly these days, deep learning. What makes deep learning, well, deep? What sets it apart?
The defining characteristic of deep learning, as the name hints, is its use of artificial neural networks with many layers, often dozens or even hundreds, hence deep.
Artificial neural networks, like inspired by the brain.
Exactly. And that's the truly profound part. Deep learning is heavily inspired by the structure and function of the human brain. It tries to mimic, in a simplified computational way, how our biological neurons are interconnected in layers and how they process information hierarchically.
So it's kind of like building a digital brain, learning in layers. How do these extra deep layers help it do things that maybe shallower ML models struggle with?
Precisely. These deep neural networks are designed to process truly vast amounts of data, think millions of images or hours of audio, and learn incredibly complex hierarchical patterns within that data. Each layer in the network learns to extract increasingly abstract and sophisticated features from the raw input.
Can you give an example, like with an image?
Sure. So in an image recognition task, the first layer of a deep network might just detect simple things like edges or corners or basic color patches. The next layer might combine those edges to recognize more complex shapes like circles or squares. Deeper layers still might then combine those shapes to identify parts of an object, say a wheel, a headlight, a window.
Building up complexity.
Exactly. And finally, the deepest layers piece together all these hierarchical features to recognize the entire object. That's a car, or that's a human face, or that's a specific breed of dog. This ability to learn hierarchical representations of data is why deep learning is behind so many of today's most impressive AI breakthroughs.
Like what specifically?
Well, highly accurate image recognition, like the kind that automatically tags your friends and photos online or powers your phone's camera features. Sophisticated language translation services like Google Translate that can capture nuance and context much better than older methods. Speech recognition that understands you even with background noise. It's what enables these systems to move beyond just simple pattern matching to achieving a kind of deeper understanding of context and intricate detail in really complex data.
Okay, so we've got machine learning, the broader field, and deep learning, the brain-inspired powerhouse within it. Now let's talk about how AI interacts with us in our own language. That brings us to natural language processing, or NLP. Expert, how does NLP give machines the gift of gab?
Right? NLP is the branch of AI focused specifically on empowering computers to understand, interpret, and crucially, generate human language. And human language is incredibly complex, isn't it?
Oh, yeah. Sarcasm, idioms, context.
Yeah, metaphors, ambiguity, implied meaning, and NLP tries to grapple with all of that. And you interact with NLP constantly, probably without even thinking about it.
Like with voice
Yeah,
assistants.
absolutely. Siri, Alexa, Google Assistant. When you ask, what's the weather going to be like tomorrow? He, NLP is working hard. First, speech recognition turns your voice into text. Then NLP parses that text, figures out your intent, you want a weather forecast for tomorrow, queries a weather database, and then generates a coherent, natural-sounding spoken response back to you.
It feels seamless, but there's a lot going on under the hood.
A huge amount. Machine translation services like Google Translate are another prime example. Chatbots that can handle customer service queries with increasingly natural conversation. Sentiment analysis that tries to understand the emotion behind text online. It's all NLP.
And I know there's been a massive leap in this area recently. Things like ChatGPT and other large language models, they seem to have come out of nowhere and are suddenly everywhere. What was the technological breakthrough that really changed the game for NLP?
You're absolutely right to point to those recent advancements. They've been stunning. What's particularly exciting in NLP and what drove this explosion are breakthroughs largely powered by deep learning, specifically using neural network architectures called transformers.
Transformers. Okay, not the movie robots.
No, not those. These transformers were a real game changer for processing language. Unlike older models that had to process text word by word sequentially, which is slow and loses long-range context.
Right, like reading one word at a time.
Transformers allowed models to process entire sequences of text, whole sentences, or even paragraphs all at once, in parallel. And crucially, they introduced something called the attention mechanism.
Attention mechanism. What's that?
It allows the AI to weigh the importance of different words in the sentence, or even across a whole document, when processing any given word. So it can pay attention to the most relevant parts of the input text to understand the context and relationships between words, even if they're far apart.
So it understands which words influence which other words.
Exactly. This unlocked an unprecedented ability to grasp nuance, context, and long-range dependencies within language. And that paved the way for these incredibly powerful large language models, or LLMs, we see today, models trained on basically the entire internet. They can generate text that's not only grammatically correct, but also coherent, contextually relevant, creative, and often remarkably human-like. They don't just mimic language. They can synthesize and generate it in ways that were, frankly, unimaginable even a decade ago.
Mind-blowing stuff. Okay, so if NLP gives machines the ability to understand and use language, then computer vision gives them sight. Expert, what does it mean for a computer to see? How does that work?
Computer vision is the field of AI that enables computers or machines to see and interpret visual information from the world around them, from images, from videos mimicking, in a sense, how human vision works. It's about going from raw pixel data to meaningful understanding.
So not just recording pixels, but understanding what they represent.
Precisely. It performs key visual tasks like object recognition, identifying what's in an image, a car, a tree, a specific person, a cat. It handles facial recognition, obviously, image classification like sorting images into categories, and even understanding complex scenes, figuring out the relationships between objects, like distinguishing between a car driving on the road and a pedestrian standing on the sidewalk, or assessing the overall activity in a surveillance video.
Okay, and what are some of the most impactful, maybe critical applications we're seeing from computer vision today? Where is it making a real difference?
Oh, the applications are hugely impactful and growing incredibly fast. Self-driving cars are a massive one. They rely utterly on computer vision, combined with other sensors, to perceive their environment, reading road signs, detecting lanes, identifying pedestrians, tracking other vehicles, predicting their movements, all in real time. It's incredibly complex.
Yeah, sounds critical.
Absolutely. Then there's medical imaging analysis. AI using computer vision can analyze X-rays, MRIs, CT scans, pathology slides, often spotting subtle anomalies or early signs of diseases like cancer or diabetic retinopathy that might be missed by the human eye, especially under pressure. This can lead to earlier diagnoses and better patient outcomes.
That's amazing.
It really is. In manufacturing, computer vision is used extensively for quality control, visually inspecting products on an assembly line for tiny defects at speeds and consistencies humans just can't match. And think about security systems, analyzing video feeds, or even in agriculture, using drone imagery to monitor crop health. It's fundamentally about giving machines a sophisticated, actionable understanding of the visual world.
And here's the really important takeaway, I think, the point that ties it all together. These four pillars we've discussed, machine learning, deep learning, natural language processing, and computer vision, they are not isolated silos. They don't just work on their own.
Not at all. That's a critical point. They frequently work in concert together.
So their combined power is what creates the really sophisticated AI systems.
Exactly. Their synergy creates incredible, powerful AI systems capable of tackling complex, real-world challenges that require multiple types of intelligence. Think about a modern autonomous vehicle again.
Okay.
It uses computer vision to see the road, the signs, the pedestrians. It uses machine learning, especially deep learning and reinforcement learning, to process that visual data.
Yeah.
Fuse it with data from other sensors like radar and LiDAR, predict the behavior of other drivers, and make split-second driving decisions.
Right.
It might use natural language processing if you're giving it voice commands, drive me to the nearest coffee shop, or if it needs to understand text from, say, a digital road sign. All of this is underpinned by powerful deep learning architectures, crunching massive amounts of sensory data in real time.
So it's the integration that's key.
It's the integration, the synergy, that allows AI systems to perceive, understand, reason about, and interact with the complex world in ways that are becoming increasingly nuanced and, well, intelligent.
Mm-hmm.
It truly is more than the sum of its parts, creating capabilities that none of these pillars could achieve alone.
Okay, that gives us a really solid understanding of the what and how of modern AI. Now let's bring it right back to your world, to you listening. How does AI actually show up in your daily life? Because you might not even realize how pervasive it truly is. It's often kind of invisible, but it's become indispensable, weaving itself into the fabric of our digital existence.
It really has crept in quietly in many ways.
Let's walk through some specific examples, things you probably use every day. Think about your voice assistants, Siri on your iPhone, Alexa on your Echo, Google Assistant on Android. When you ask them the question, what's the capital of France? Or tell them, set a timer for 10 minutes or play my workout playlist. They're not just recognizing sounds, they're using sophisticated natural language processing to understand the meaning of what you're saying, figure out your intent, fetch the right information or trigger the right action, and then respond naturally. It feels almost magical, but it's complex AI working in milliseconds.
Seamless interaction, driven by NLP and often cloud-based AI.
Then there are recommendation systems. Have you ever stopped to wonder how Netflix always seems to know exactly what you want to watch next? Or how Amazon suggests products that feel weirdly perfect for you? Or how Spotify crafts those Discover Weekly playlists that just nail your taste?
It can be uncanny sometimes.
It really can. That's AI. Behind the scenes, powerful algorithms are constantly analyzing your preferences, what you watch, what you buy, what you listen to, what you skip, what you rate highly. They compare your behavior to millions of other users, identify subtle patterns, group you with people who have similar tastes, and then personalize your experience. They're essentially anticipating your needs and guiding your choices, introducing you to new things you're statistically likely to enjoy.
Using unsupervised learning often to find those clusters of similar tastes.
Right. And what about the things working silently in the background, like spam filters and fraud detection? These are kind of the unsung heroes of the AI world, aren't they?
Absolutely. Critically important, but invisible when they work well.
Your email spam filter uses machine learning, often supervised learning, trained on billions of emails to identify suspicious patterns, weird sender addresses, malicious links, common scam phrases. It blocks junk before it even hits your inbox.
Constantly learning and adapting to new spam tactics, too.
And similarly, fraud detection systems used by your bank or credit card company are analyzing literally billions of transactions in real time. They use AI to look for anomalies, patterns that deviate from your normal spending behavior, maybe a sudden large purchase in a city you've never visited. They flag potentially fraudulent activity instantly, protecting your finances. It's a massive AI operation running 24/7.
A critical layer of security we often take completely for granted.
And finally, something maybe even simpler, just unlocking your phone. Facial recognition on phones, that's advanced computer vision. It analyzes dozens, maybe hundreds, of unique biometric points on your face in a split second, compares them to a securely stored template, and performs complex calculations to verify it's really you. Incredibly convenient, incredibly secure, all powered by sophisticated AI running right there on your device.
Edge AI, often.
Mm-hmm.
And what's truly remarkable about all these examples, the voice assistants, the recommendations, the security features, the face unlock, is how subtly yet powerfully AI enhances both convenience and security in your personal life.
Yeah.
It's not about, flashy robots taking over in these cases. It's about making your everyday interactions with technology smoother, safer, more personalized, and frankly, just more intuitive. AI is the invisible handmaking. Many of the digital experiences you rely on just work better.
It really has become embedded. Okay, so beyond our personal gadgets and online experiences, AI is having an absolutely transformative impact on major industries worldwide. The scale of change is staggering, pushing boundaries, creating efficiencies that were, well, just unimaginable even a few decades ago.
The industrial and scientific applications are where you see some of the most profound shifts happening.
Let's dive into some key sectors. Take healthcare. This is a huge one. AI is genuinely revolutionizing diagnostics. We talked about computer vision. AI models can analyze complex medical images like X-rays, MRI, CT scans, pathology slides, and detect signs of diseases like various cancers, Alzheimer's, diabetic eye disease, sometimes with greater accuracy or speed than human experts. They can flag tiny anomalies a radiologist might miss on a busy day.
Augmenting the clinician, helping them be more effective.
Exactly. And it's also dramatically assisting in drug discovery, simulating how molecules interact, predicting the potential effectiveness or toxicity of new drug candidates. This can massively accelerate the incredibly long and expensive process of developing new medicines.
Shaving years and potentially billions off the development cycle.
We're also seeing the rise of personalized medicine. AI can analyze an individual's unique genetic makeup, their lifestyle data, their medical history, to predict how they might respond to specific treatments. This allows doctors to tailor therapies for unprecedented precision, moving away from a one-size-fits-all approach. It's a massive shift towards individualized care.
Huge potential for improving outcomes there.
Now, let's switch gears to transportation. Obviously, self-driving cars get a lot of headlines.
They do. The ultimate AI challenge in some way.
They rely incredibly heavily on that blend of computer vision, sensor fusion, combining data from cameras, LiDAR, radar, and machine learning, especially reinforcement learning, to navigate complex and unpredictable real-world environments. It's a monumental task.
Still very much a work in progress, but advancing rapidly.
But AI in transportation is much broader than just autonomous cars, right?
Oh, absolutely. AI is being used to optimize complex traffic flow in big cities. Using real-time data from cameras, road sensors, even GPS data from phones, AI can adjust traffic signal timings dynamically, suggest alternate routes to drivers via navigation apps, all to minimize congestion and travel times.
Smart cities, basically.
A part of it, yes. It's also revolutionizing logistics, managing massive shipping operations, optimizing delivery routes for fleets of trucks or drones to save fuel, reduce emissions, and get packages delivered faster. And it's significantly enhancing aviation safety. Airlines use AI to analyze vast amounts of flight data and sensor readings from engines for predictive maintenance.
Meaning they can predict failures before they happen.
Exactly. Identifying potential equipment failures in aircraft before they become critical issues, allowing maintenance to be scheduled proactively. This makes flying safer and reduces costly delays and cancellations.
Okay, how about manufacturing and robotics? We often picture robots on assembly lines. How is AI changing that?
Well, those AI-powered robots are becoming much more capable. They're not just doing simple repetitive tasks anymore. They can perform increasingly complex assembly, welding, painting, inspection tasks with incredible precision, speed, and consistency. 247. This boosts efficiency and quality massively in sectors from automotive to electronics.
Beyond just doing the tasks, is AI helping manage the factory itself?
Yes, hugely. A key application is predictive maintenance here too, but for factory machinery. AI analyzes real-time sensor data vibrations, temperature, noise levels, energy use from crucial equipment on the factory floor. It learns the normal operating patterns and can then anticipate when a machine is likely to fail before it breaks down.
So they can fix it during planned downtime.
Precisely. Instead of a costly, unexpected shutdown stopping the whole production line, they can replace parts proactively. This saves companies potentially millions in avoided breakdowns, repairs, and lost production time. It's a massive efficiency gain.
Let's touch on education. How is AI impacting learning? Is it just about replacing teachers?
Not at all about replacing teachers, more about augmenting them and personalizing the experience for students. AI is being used to create personalized learning platforms. Imagine adaptive textbooks or online learning systems that adjust the content, the difficulty level, and the pace based on how an individual student is doing.
So if I'm struggling with algebra, it gives me more practice.
Exactly. Or if you're excelling, it might offer more challenging problems or enrichment material. It can provide intelligent tutoring systems tailored to individual needs, offering immediate feedback, hints, and targeted exercises. For instance, an AI tutor might notice a student consistently makes the same type of grammar mistake and then generate specific exercises focusing just on that rule. It aims for a more effective, engaging, and potentially more equitable learning journey for each student.
That sounds incredibly useful. What about other fields? Maybe something less obvious, like agriculture?
Yes, agriculture is another fascinating area. AI is being used to make farming much more efficient and sustainable. Think AI-powered drones equipped with cameras and sensors flying over fields.
What are they looking for?
They're monitoring crop health, identifying areas affected by pests or disease early on, assessing soil moisture levels. Computer vision analyzes the imagery. AI can then predict crop yields with greater accuracy, help farmers optimize irrigation schedules, watering only where and when needed, or guide precision application of fertilizers or pesticides, reducing waste and environmental impact. It's leading to what's called precision agriculture.
Wow. So AI is helping us grow food more sustainably.
In many ways, yes.
Yeah.
The overarching theme, the real beauty of AI's application across all these diverse sectors, healthcare, transport, manufacturing, education, agriculture, finance, you name it, is its incredible versatility.
Right.
It excels at automating repetitive or dangerous tasks, freeing up human workers for more complex, creative, or strategic thinking. It can analyze massive, complex data sets far beyond human capacity to uncover hidden insights, correlations, and trends that we might completely miss. And critically, it can make predictions about future events, from equipment failure to disease outbreaks to market trends, with a level of accuracy and speed that was previously unimaginable.
So this widespread adoption, it's really driving efficiency and innovation globally.
Absolutely. It's a major engine for efficiency, innovation, and progress in nearly every facet of modern life, allowing us to tackle challenges, optimize systems, and create value on a scale we simply couldn't before.
Now, this all sounds incredibly promising, and much of it is. But with such transformative power, as we hinted earlier, comes a real need for careful consideration. The public conversation around AI, rightly so, often centers on... Okay, so let's tackle one of the most frequently discussed concerns first. The issue of bias in AI systems. How does bias creep into AI? It's just code, right?
If only it were that simple. The core issue is that AI systems, particularly machine learning models, learn from the data they are trained on.
Right, we established that. Learn from data.
So if the data itself reflects existing societal biases, historical inequalities, or skewed representations, whether those relate to race, gender, age, socioeconomic status, language, anything in the AI system will learn those biases as patterns. It doesn't know their biases, it just sees them as correlations in the data.
So it learns our prejudices.
It can, yes.
Yeah.
It learns to associate certain groups with certain outcomes simply because that's what the historical data shows, even if those associations are unfair or discriminatory. And it can then perpetuate or even amplify those biases when it makes predictions or decisions in the real world.
And the real-world consequences of this are pretty serious, right? Where might we see biased AI causing problems?
The implications are significant, especially when AI is used in high-stakes areas. Think about algorithms used for screening job applications. If trained on historical hiring data that favored a certain demographic, the AI might learn to unfairly filter out qualified candidates from other groups.
Wow.
Or loan applications. An AI might deny loans to people in certain neighborhoods based on historical data, perpetuating redlining. Risk assessments in the criminal justice system have faced heavy criticism for potential racial bias learned from historical arrest data. Even in medical diagnoses, an AI trained primarily on data from one demographic might be less accurate for others. The concern isn't usually about AI being intentionally malicious. It's about it faithfully, mathematically, reflecting the biases embedded in the data we feed it.
So what can be done about this? How do we mitigate AI bias?
It's a major focus of research and ethical AI development. It requires a multi-pronged approach. First, ensuring that the training data used is as diverse, representative, and fair as possible. This might involve actively collecting more data from underrepresented groups or using statistical techniques to rebalance datasets.
Okay, better data in.
Better data in is crucial, but it's not enough. It also requires rigorous auditing and continuous monitoring of AI models after they're deployed. We need tools and processes to test for bias, to see if the model is performing differently for different groups, and mechanisms to correct unfair patterns if they emerge. Transparency about how models are built and what data they use is also key. It's an ongoing, active challenge demanding constant vigilance from developers, deployers, and policymakers.
Okay, data bias is a big one. Another major area of concern is privacy and data security. You mentioned earlier that AI often needs vast amounts of data to work well.
Especially deep learning models, yes, they thrive on data.
So that immediately raises fundamental questions, doesn't it? How is all this data being collected? Sometimes without us even realizing it. How is it stored securely? How is it being used? And critically, how is it protected from misuse or from hackers and data breaches?
Absolutely. There's a very delicate balance we need to strike here. On one hand, we want to leverage the immense benefits that AI can offer through analyzing large data sets, improving healthcare, making cities smarter, personalizing services. On the other hand, we have to safeguard fundamental individual privacy rights.
It feels like a trade-off sometimes. More data means better AI, but less privacy.
It can feel that way, and navigating that tension is key. The more personal or sensitive the data an AI uses, the more powerful it might become, but also the greater the potential harm if that data is misused or compromised. Regulations like Europe's GDPR, General Data Protection Regulation, and California's CCPA, California Consumer Privacy Act, are important steps. They establish frameworks for data protection, user consent, transparency, and giving individuals more control over their data.
Are they enough?
They're a good start, but the technological landscape is evolving so rapidly. New ways of collecting and analyzing data emerge constantly, so there's an undeniable need for ongoing vigilance, for developing even more robust security measures like encryption and anonymization techniques, and for adaptive policies and ethical guidelines in how organizations handle data, especially for AI training and deployment. Transparency about data practices is absolutely crucial for building public trust.
Let's talk about the elephant in the room for many people, job displacement. This comes up constantly. As AI gets better at automating tasks, especially repetitive ones or those involving data analysis, is it going to put millions of people out of work?
It's a legitimate concern, and probably one of the most widely discussed societal impacts of AI. It's natural to fear that automation will lead to job losses, and historically, technological revolutions have displaced workers in certain sectors.
Like weavers with the power loom or factory workers with industrial robots.
Exactly. So it's very likely that AI will automate certain tasks currently performed by humans, particularly those that are highly structured, repetitive, or data-intensive. Some jobs may indeed disappear or change significantly.
But is it all doom and gloom?
Not necessarily. It's important to have a balanced perspective. While some jobs might be lost, AI is also strongly expected to create entirely new jobs roles that we can't even fully imagine yet, centered around designing, developing, managing, and working alongside AI systems. Think AI trainers, data curators, AI ethicists, prompt engineers.
Okay, new roles emerging.
And perhaps more significantly, AI is likely to augment human capabilities in many existing roles. It can handle the tedious parts of a job, freeing up humans to focus on tasks requiring creativity, critical thinking, complex problem solving, emotional intelligence, and interpersonal skills areas where humans still vastly outperform AI. A doctor might use AI for initial image analysis, but they still need to interpret the findings in context, communicate with the patient, and make the final treatment decision.
So the key is adaptation, preparing the workforce.
Absolutely. Societal preparation for these shifts is critical. This means investing heavily in education and retraining programs to equip people with the skills needed for the future of work skills that complement AI, rather than compete with it. It might also involve exploring new economic models, like universal basic income or adjusted social safety nets, to ensure a just transition for those whose jobs are most affected. The ultimate goal, arguably, should be to use AI not just to replace human labor, but to elevate human potential, allowing us to focus on more meaningful and complex work.
This raises another crucial point, accountability and transparency. When an AI system makes a decision, especially a really important one with significant consequences, say, a medical diagnosis that turns out to be wrong, or an autonomous car causing an accident, or an AI used in a legal ruling, who is responsible?
That is a deeply challenging question.
And compounding that, can we even understand how the AI arrived at its decision? This is often called the black box problem, right?
Precisely. That's the black box phenomenon. Many advanced AI models, especially complex deep learning networks with billions of parameters, are so incredibly intricate that their internal decision-making processes are opaque, even to the engineers who build them. We can see the input data, we can see the output decision, but the step-by-step reasoning or the internal weighting of different factors that led to that specific output can be incredibly difficult, sometimes impossible, to fully interpret.
So if we don't know why it made a decision, how can we trust it? Or hold anyone accountable if it's wrong?
That's the crux of the issue. This lack of transparency poses significant challenges for debugging errors, ensuring fairness, building trust, and establishing legal and ethical accountability. If an AI denies someone a loan, they have a right to know why. But the AI might not be able to provide a clear, human, understandable explanation.
So what's the solution? Are researchers working on this?
Yes, very actively. This is why the field of explainable AI, or XAI, is so incredibly important. It is a major area of research right now. XAI aims to develop techniques and methods to make AI decisions more transparent, interpretable, and understandable to humans.
How would that work?
It involves various approaches, designing models that are inherently more interpretable, developing tools that can visualize or approximate the reasoning process of complex models, or generating explanations for specific decisions. The goal is to open up the black box, at least partially, so we can understand, trust, and manage AI systems more effectively, especially in critical applications like healthcare, finance, and justice. Imagine an AI recommending a specific medical treatment. With XAI, a doctor could potentially see why the AI made that recommendation, which patient factors it weighed most heavily, not just what the recommendation was. That builds trust and allows for informed oversight.
Okay, that seems vital. And finally, stepping back even further, there's the broader, perhaps more long-term consideration of control and safety. As AI systems become more autonomous, more capable, maybe even more generally intelligent, how do we ensure they remain aligned with human values and goals? How do we keep them safe and under control?
This is where the conversation often touches on more futuristic and sometimes unsettling scenarios. It's about ensuring that as AI capabilities grow, potentially surpassing human capabilities in various domains, these systems consistently act in ways that are beneficial or at least not harmful to humanity.
Are we talking about the superintelligence risk here? AI deciding humans are in the way?
That's the extreme sci-fi end of the spectrum. And while debated, it's not the immediate concern for most researchers. The more near-term and practical challenge within AI safety is ensuring that even current and next-generation AI systems, which are becoming more autonomous in complex environments, like driving cars or managing power grids, behave predictably and reliably, don't exhibit unexpected or harmful behaviors due to unforeseen interactions or edge cases, and have robust mechanisms to prevent accidents or unintended consequences. It's also about the alignment problem. How do we specify complex human values and intentions in a way that an AI will reliably understand and follow, especially as it learns and adapts?
So it's less about malevolent AI and more about competence and alignment, making sure it does what we intend it to do safely.
Exactly. It's a profound philosophical and technical challenge. How do you encode complex concepts like fairness or well-being into code? As AI systems become more capable of long-range planning and operating autonomously, ensuring their goals remain robustly aligned with ours becomes increasingly critical. It demands careful, proactive consideration from the research community, emphasizing the need for rigorous testing, formal verification methods, built-in safety protocols, ethical frameworks, and mechanisms for human oversight right from the design stage. It's about building trustworthy AI from the ground up.
It really underscores that addressing all these ethical and societal challenges, bias, privacy, jobs, accountability, safety, it isn't just some side issue or academic exercise.
Not at all.
It feels fundamental, absolutely essential if we want to build an AI future that is equitable, safe, and genuinely beneficial for all of us, rather than a future that deepens divides, creates new risks, or benefits only a select few.
And achieving that absolutely necessitates collaboration. This can't be left just to the tech companies or just to the researchers. We need technologists working closely with ethicists, social scientists, policymakers, legal experts, and the public at large. It has to be a collective societal effort to navigate these complex issues responsibly, ensuring that the incredible power of AI is steered towards positive outcomes and its development proceeds with foresight, wisdom, and empathy.
So looking ahead then, what does the future hold for artificial intelligence? Predicting tomorrow is always a bit of a mug's game, isn't it? Especially in a field moving as lightning fast as AI.
It changes month by month sometimes, it feels like.
It really does. But we can definitely identify several key trends and exciting possibilities that researchers and innovators are actively pushing towards right now. These give us a hint of what might be just around the corner, shaping our world even more profoundly.
This is really a glimpse at the cutting edge, yeah. Looking at where the research is heading and what capabilities might soon become reality, it's about understanding the trajectory, thinking about where all these foundational pieces we've discussed are leading us.
Okay, let's start with the big one, the one that often grabs headlines. Artificial general intelligence, or AGI. You hear this term thrown around. What exactly is it, and how is it different from the AI we have now?
Right, so almost all the AI systems you interact with today, from your spam filter to ChatGPT to a self-driving car system, are considered narrow AI or weak AI.
Meaning they're good at one specific thing.
Exactly. They're highly skilled, maybe even superhuman, but only within a very specific narrow domain. ChatGPT is amazing at language tasks, but it can't drive a car or diagnose a disease from an X-ray. Deep Blue was brilliant at chess, but useless for anything else. AGI, or strong AI, is the hypothetical future AI that would possess human-level cognitive abilities across a wide range of tasks.
So like a human brain's flexibility.
Kind of. It would be capable of learning, understanding, reasoning, and applying intelligence to potentially any intellectual problem that a human being can tackle. It could learn a new skill, transfer knowledge from one domain to another, use common sense, understand context deeply, exhibit the kind of flexible, adaptable intelligence we associate with humans. That's why it's often called the holy grail of AI research.
Is it close? Are we near AGI?
That is the billion-dollar question, and opinions vary wildly. Some researchers think it's decades away, maybe centuries, maybe never. Others are more optimistic, pointing to the rapid progress in areas like large language models. While current LLMs are definitely not AGI, their surprising emergent abilities, being able to perform tasks they weren't explicitly trained on, showing sparks of reasoning, applying knowledge across contexts, are seen by some as bringing us closer to systems that exhibit more generalized capabilities.
So maybe steps on the path, but not the destination itself.
That's a good way to put it. They suggest a possible pathway, however long and uncertain, towards systems that are less narrowly specialized and possess broader intelligence. The ability of an LLM to discuss quantum physics one minute and then write a decent poem the next hints at that kind of generality, even if the underlying mechanisms are still pattern matching on a massive scale. But true, human-like general intelligence remains a profound challenge.
Okay, moving on from AGI, another really exciting frontier and one we're seeing practical progress in right now is multimodal AI.
Yeah.
Expert, what does it mean for AI to be multimodal?
Multimodal AI refers to systems that can process, understand, and integrate information from multiple different types of data or modalities simultaneously. Think about how humans experience the world.
We use all our senses, right? Sight, sound, touch.
Exactly. We don't just process text or just images or just sound in isolation. We integrate them. When you have a conversation, you hear the words, audio, see the person's facial expressions and gestures, video images, maybe read something they point to, text. Multimodal AI aims to replicate that holistic understanding by handling text, images, audio, video, maybe even sensor data like temperature or motion, all at the same time.
So paint us a picture. What could an AI do if it could handle all those different inputs together? What new capabilities does that unlock?
Well, imagine an AI assistant you could interact with much more naturally. You could ask it a question verbally while showing it an object with your phone camera and maybe pointing to a specific part on the screen. The AI could process your voice, the video feed, understand your gesture, maybe even read text on the object and then synthesize a coherent response using all that combined information.
Wow, that sounds much more like talking to another person.
It leads to much more intuitive and powerful human-AI interactions, feeling far less clunky and more truly intelligent. It also opens up huge possibilities for richer data analysis. Think security systems analyzing video feeds alongside audio sensors, or entertainment systems that understand the emotional tone of a movie scene from both the visuals and the soundtrack. Or diagnostic medicine, where a doctor might feed an AI a patient's written medical history, text, their X-ray scans, images, and recordings of their symptoms like a cough audio to get a far more comprehensive analysis than any single modality could provide. It's about creating a more complete contextual understanding of the world.
And we're already seeing models that can generate images from text or describe images in text. That's a form of multimodality, right?
Yes, exactly. Those are early examples of bridging different modalities, and the capabilities are expanding incredibly fast.
Speaking of generation, we're seeing explosive growth in AI's ability to create totally new content. This is the realm of generative AI, which includes things like ChatGPT, but also image generators and more.
Generative AI is definitely one of the hottest areas right now. We already have these incredibly powerful tools. You give them a text prompt like a photo of an astronaut riding a horse on the moon, and they create a surprisingly realistic image.
Or tools that write compelling marketing copy, draft emails, summarize long documents, write computer code.
Compose original music in the style of Bach or Taylor Swift.
Yeah.
Create realistic sounding synthetic voices. Generate deepfake videos. The range of creative capabilities is just astonishing and growing daily.
What are the implications of AI becoming so good at creating?
The implications are profound and will ripple through many industries. Obviously, creative fields like advertising, graphic design, writing, music production, game development, they're already being disrupted and transformed. Content can be generated much faster, personalized at scale, maybe new forms of art will emerge.
But it goes beyond just creative industries, right?
Oh yes, generative AI is also poised to accelerate scientific discovery significantly. Researchers are using it to generate new scientific hypotheses based on existing literature, design novel molecules or materials with desired properties for drug development or material science, or even generate synthetic data to train other AI models when real-world data is scarce. Its ability to synthesize new, coherent, and potentially useful information or artifacts from learned patterns is a powerful tool for innovation across the board.
Okay, let's shift from the cloud to the device itself. We're hearing more about edge AI. What is that and why is it important?
Edge AI basically means running AI algorithms directly on the local device itself, like your smartphone, a smart camera, an industrial sensor, a car, or a robot, rather than sending data to a powerful server in the cloud for processing and then getting the result back.
So the intelligence is at the edge of the network on the device.
Exactly, and this offers several significant advantages over purely cloud-based AI, addressing some of its key limitations.
Like what? What are the benefits?
Well, first is speed and reduced latency. Because the data doesn't have to make a round trip to the cloud and back, processing can happen much faster, often in near real time. This is critical for applications where instant decisions are needed, like collision avoidance in a car or controlling a robot's movement.
Makes sense. What else?
Second is enhanced privacy and security. By keeping sensitive data localized on the device, instead of transmitting it over the internet to a central server, you reduce the risk of that data being intercepted or breached. This is really important for personal data like health information or facial recognition data.
Right, keeping data local.
Third is improved reliability and reduced reliance on internet connectivity. Edge AI applications can continue to function even if the internet connection is slow, intermittent, or completely unavailable. This makes AI much more practical for deployment in remote locations, on moving vehicles, or in situations where constant connectivity can't be guaranteed.
So what kind of new applications does edge AI enable?
It's opening up a whole new wave of applications that require that real-time response, privacy, or offline capability. Think autonomous drones that can navigate and make decisions independently while flying in remote areas without a signal. Smart home devices that can process your voice commands locally without sending recordings to the cloud. Wearable health monitors that can analyze your biometric data right on your wrist, providing immediate alerts and preserving your privacy. Industrial sensors that detect anomalies in machinery instantly on the factory floor. It's about distributing intelligence closer to where the data is generated and where the action needs to happen.
And speaking of devices taking action, the accelerating integration of AI and robotics seems like a major trend too. Robots are getting smarter.
They absolutely are. AI is the brain that's making robots far more capable and adaptable than ever before.
So how is AI changing robotics? What can these smarter robots do?
As robots become more intelligent, they're better at perceiving their surroundings through advanced sensors and computer vision, more adaptable through machine learning, and increasingly capable of learning from experience in their environments, using reinforcement learning, for example. They're starting to move far beyond the highly structured, repetitive tasks in controlled factory settings.
Moving out into the real world.
Exactly. We'll see them increasingly operate effectively in more dynamic, complex, and unpredictable real-world scenarios. Imagine AI-powered robots assisting elderly people with daily tasks in their homes. Robots performing complex tasks in hazardous environments that are unsafe for humans, like nuclear decommissioning, deep-sea exploration, or bomb disposal. Or highly precise robotic assistants aiding surgeons in the operating room. Their ability to perceive, reason, learn, and act intelligently and physically in the world is expanding rapidly.
So more automation, but also more assistance in complex tasks.
Both. It promises new forms of automation, yes, but also new ways for robots to collaborate with humans, enhance our capabilities, and take on dangerous, difficult, or monotonous tasks across a huge variety of domains, from logistics and construction to healthcare and exploration.
And finally, let's think really big picture. How might AI contribute to tackling some of the world's most pressing global challenges?
This is where AI's potential impact could be truly profound. Its ability to analyze vast, complex data sets and identify patterns or optimal solutions makes it an incredibly valuable tool for addressing huge systemic problems.
Give us some examples. How can AI help with things like climate change or disease?
Okay, climate change. AI is being used for much more accurate climate modeling, processing enormous amounts of satellite data, ocean sensor readings, and atmospheric measurements to predict climate patterns,
Hmm.
understand the impact on ecosystems, and help develop more effective mitigation and adaptation strategies. It can also help optimize energy grids for efficiency and better integrate renewable energy sources like solar and wind.
Okay, climate and energy. What else?
Personalized medicine, as we discussed, has the potential to scale globally, improving healthcare outcomes for millions by tailoring treatments. AI can also help track and predict the spread of infectious diseases by analyzing news reports, social media data, and travel patterns, enabling faster public health responses. In sustainable agriculture, AI helps optimize resource use water, fertilizer, making food production more efficient and less environmentally damaging. And in disaster response, AI can rapidly analyze satellite imagery, drone footage, and social media feeds after an earthquake or hurricane to identify damaged areas, locate survivors, and help coordinate aid and rescue efforts much more effectively.
So it's really about harnessing its analytical power for the greater good.
Exactly. AI's unparalleled ability to process complexity, find signals and noise across vast datasets, and identify optimal solutions makes it an invaluable tool for accelerating progress on many of humanity's grand challenges.
So it really feels like, as you said, the future of AI isn't just about the technology itself getting better and faster. It's profoundly about how we choose to integrate these incredibly powerful tools into our society, into our lives. It's a choice we're making right now collectively with every algorithm we deploy, every product we build, every policy we enact.
That's a crucial point to end this section on. This future isn't predetermined. It's not just going to happen to us. It demands careful consideration, proactive and thoughtful policymaking, ethical reflection, and an unwavering commitment from researchers, developers, governments, and the public to ensure that AI genuinely serves humanity's best interests. It's about consciously building a future where AI enhances our lives, helps us solve our biggest problems, and empowers everyone rather than creating new divides or risks.
So, as we start to wrap up our journey today through the AI revolution, it's just abundantly clear, isn't it? We are living in an era of unprecedented technological change. Artificial intelligence isn't just science fiction anymore.
Not even close.
It is a tangible, powerful force that is reshaping our world at an astonishing, sometimes bewildering pace. We've explored its foundational concepts today, going way back to those ambitious dreams at Dartmouth in the 1950s, right up to the modern marvels of machine learning and deep neural networks that are literally powering the devices in your pocket and the services you use online every day.
From symbolic logic to statistical learning, a huge shift.
We've seen how AI isn't just a tool for simple automation anymore, but a catalyst for incredible innovation across pretty much every conceivable industry, from making healthcare diagnostics sharper to optimizing global supply chains to helping us understand climate change better.
Transforming science, business, and daily life.
And crucially, we've also tried to grapple with those profound societal and ethical questions that inevitably arise, the valid concerns about fairness and bias, about protecting our privacy in a data-hungry world, about the future of work and job evolution, and about ensuring accountability and safety as these systems become ever more complex and autonomous.
The challenges are just as real as the opportunities.
Exactly. And what's so important to remember listening into all this is that the future of AI, as you just said, it's not predetermined. It's not written in stone.
No, it's being actively built by us. Through the choices we make today as developers choosing algorithms, as policymakers crafting regulations, as businesses deploying systems, and even as individuals deciding which AI tools to use and how.
It really calls for informed public discussion, doesn't it? And responsible development practices and a truly collaborative effort to harness AI's immense potential for good while working diligently and proactively to mitigate its risks.
Couldn't agree more.
So understanding AI, hopefully after listening today, empowers you, the listener, to engage with this technology more critically, more thoughtfully. It gives you the insight not just to use AI, but to question it, to understand its implications, and maybe to be an active participant in shaping its trajectory.
And as a society, it really challenges us, doesn't it? It challenges us to envision and then actively build a future where AI genuinely enhances human flourishing, where it helps us solve our most complex shared problems, and where it creates entirely new opportunities for everyone, not just for a select few. It's ultimately about leveraging intelligence, whether artificial or human, to try and create a better world.
So here's a final thought for you to take away. As you go about your day today, tomorrow, and you inevitably interact with an AI-powered system, maybe it's asking your voice assistant a question. Maybe it's getting that oddly specific movie recommendation. Maybe it's just noticing how your smart thermostat learns your schedule. Consider this. How do your daily, perhaps unnoticed interactions with these intelligent systems and the constant stream of data you generate by using them, how does that collectively shape the ethical landscape and the future capabilities of AI, maybe for generations to come? What will your contribution, however small, to this intelligent future actually be? Thank you so much for joining us on this deep dive into the world of AI. Keep learning, keep questioning, and let's try to navigate this intelligent future together.